Okay, we're back with the second video in the loops and arrays unit. I don't even know what to call these. But yeah, the second video in this, and in this one, we just went over arrays in the previous video, so now we're going to go over loops. So what is a loop? Well, a loop is anything that runs a certain amount of code, a set amount of, or a certain amount of times until a condition is met, or until you tell it to stop. Which is really useful because you guys might have seen in, like, for example, your calculator project, doesn't it suck to click that run button over and over again? You want to just kind of let the code keep doing its thing. You don't really power on your calculator every time. You give it an equation, you click enter, you get your result, it's still on. So what's happening is there's a loop there. It is constantly checking for input. It doesn't just get its input, spit out its answer, and quit on you, right? So before we get into exactly how that works, let's go over like a little simpler version of a loop, which is something called a for loop. A for loop is used to make sure a program or a thing, a block of code, runs a certain amount of times. So the exact syntax for a for loop is, I guess, a little more complicated than anything that you guys have seen before. So for now, what I would like you guys to do is copy this down, except for the green stuff inside. Copy it down word for word, and I'll give you like a little bit to do that. And then I will go over each part with you, and then you can just kind of make notes in the margins for yourself if you need to. Be sure to be really accurate with what you type down, because a little mess up could change how the loop works. Okay, so the very first thing before this first semicolon is the initial condition of the counter variable. So there's two things that are introduced there, the counter variable and the initial condition of it. So the counter variable is essentially something you create when you make your for loop that checks, is traditionally used to check how many times this loop has been done or finished through. And it is incremented by a certain amount that we will talk about later at the end of each loop, and this is the number that it starts at. The second part of this loop is called the run condition. Essentially, this loop will run as long as that statement, when it's checked, returns true. So what this means is that, as long as my counter variable, I, is below 5, which means it can be negative anything, to 0, 1, 2, 3, and 4. It cannot be 5 because 5 is less than 5 returns false, because 5 is not less than 5. But essentially what this is saying is that, hey, we're going to run this loop until I is equal to or greater than 5. Essentially is what this is saying. And finally, this last part right here is the incrementation. I++, you may not have seen this notation before, but essentially means I, whatever the value of I is, add 1 to it. So increment I by 1. So if we put this all together, what it says is we're going to start off I at 0. Every time the loop runs, we're going to increment it by 1. Remember, this happens at the end of the loop. So if I were to put it in code, it would happen incrementation happens here at end. And then the checking will happen before the loop even executes. So say, for example, we run this loop for the very first time, right? All right, I equals 0. Is 0 less than 5? Yes, so the loop will run. At the very end, it increments. So now our I is 1. Check again. Is I less than 5? Yeah, you're good. Run the loop again. Now I changes from 1 to 2, because 1 plus 1 is 2. Goes to 3, goes to 4, and then it's 4. And we're getting to like the danger zone right here. 4 is less than 5. That returns true. So we're going to run the code. And then finally we increment it and it becomes 5. 5 is not less than 5. Java will check that, say, all right, the counter variable no longer gives us true in this statement right here. So this loop is done. And then what that says to Java is keep going. Just, all right, your for loop is done. Keep on going. So that's how you can keep track of how many times it's run. So how many times did this loop run if I was to run it right here? Well, we can check. This little print right here simply prints out the iteration plus I, the value of I every single iteration. So our loop ran 5 times. You see the number 5 right there. However, the values ranged from 0 to 4. Now, if you're connecting this back to arrays, you can see how this is extremely helpful. we went through the loop, the for loop, 5 times. However, the numbers we went through were 0 to 4. Now, if you look at the array, it has a size of 5. There are 5 things in it, but it's a 0-based index. So you'd only go up to 4. This is exactly why we need for loops for arrays. They help us iterate through arrays. Now, before I actually get into like how we exactly do that in this next part right here, I just want to show you the flexibility of for loops. I can set I equal to 5 to begin with, and I can say, oh, as long as I is greater than 0, or greater than or equal to 0, subtract I minus minus. I can run that. Now it goes from 5, 4, 3, 2, 1 to 0. Just like that, we reverse the loop. Now this is for array of size 6, but we don't have to really get into that. That's what, when you fiddle with it, make sure the equals and the less thans are all correct. And you can put, like I just put here, equal to. I can also remove this and run it here, and it'll just give me 5 to 1 instead, because of course it won't run when it's 0, because it's very important to know the order of this. The checking happens before the execution. The incrementation or decrementation happens at the end of the execution, and everything in between is the code. So if you need to replay that, just write that down, because that's pretty important to understand how these for loops work. All right, let me just get that out of there. So now, how would we exactly iterate through an array? Say we have an array and we don't actually know how long it is. How do we make sure that this number right here, this checking condition, is actually, oh, whoops, wrong button. How do we check that this condition will work for that array and we won't try to access element 200 of an array of size 3? Well, how we do that is the method I explained to you guys in the previous video, which is the .length method. So what we do is this. We start off at 0. We say as long as I is less than myArray.length, increase I by 1. So you might think, oh, but won't this go up to the array length, which say, for example, is 5? But there is no index 5 in an array of length 5 because the biggest index is 4. Remember, minus 1. Well, this is why the whole less than and not less than and equal to works in this situation. Because what this will do is the very first iteration will be 0. Second one, it'll be 1. Third one, it'll be 2. First, second, third. Fourth one, it'll be 3. And fifth one, it'll be 4. You subtract 1 from each. And this is perfect for accessing my array because these are the exact same numbers that we can use to access the elements of the array. And myArray.length, if you just use this, lets you change the length of my array. Say I want my array to actually be length 7, and I'm going to add my array 5 is equal to 220, and my array 6 is equal to 400. Now, if I was to print out 5, 6, sys out, and I'm going to do my array, and I'm going to do I, because you put I in here, because I is the number that is changing every single iteration. And then I'm going to do plus I. So you can see the number, which I is, and also the value that is accessing within the array. So if I click run, see right here. So the 0th element is 77. First element is 22. Sorry, the 0th index is 77. First element is 77 as well. The first index is 22. Second index is 12, and so on and so forth. This is how for loops mesh perfectly with these arrays. You can use for loops to check through these arrays, save a bunch of data, and you're like, oh, the best example of this is when you have an array and you want to really elegantly display the data. So you say at index, and then I put I here, and then I'll put like a comma, the value in my array is, and then I will put my array, and then I'll just put I there. So this will really elegantly tell us at each index what the value is. At index 0, my array, and so on and so forth. And to do this without a for loop would be tedious. You'd have to literally write each statement out, but a for loop lets you automate this and just really just writes it out quickly. That's the power of for loops. And you'll see in the problems I'm going to give you that they're necessary. I think it'd be near impossible to write some of these programs without loops. So moving on to, I guess, the little more complicated version of a loop, nested for loops. So this is where the mind F stuff starts happening. And trust me, this stuff gets me too. Like, I have to genuinely think about nested, like triple nested for loops. Sometimes I used that once. That was hell. But for loops, really just nested for loops, because you keep track of what happens each time. So how nested for loops work is this. A for loop, after all, is just a block of code. It runs like any other block of code. So when the outer for loop runs a set amount of times, the inner for loop will execute its amount of times that many amount of times. For example, I'm just going to remove this for a second. Say I have 5 and 5. So obviously, as we've seen before, this outer loop, this for loop that has the variable I as the beginning, by the way, you can't name the inner variable I. Usually you stick with J. That one that has I at the beginning, that will run 5 times. Now, what is the code that is being run 5 times? What is being run 5 times is code that runs 5 times. So 5 times 5 is 25. And I can prove that to you by, if I just do sysout one run. Now this is 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. That is definitely 25 times. Just take my word for it. That one run ran 25 times just with this nested for loop, because, well, the outer loop runs 5 times, and for each one of those iterations, there are 5 J loops running. So, okay, when I is 0, J goes from 0 to 4, and then exits that loop, and then the loop completes. I gets incremented to 1. J once again starts at 0 and goes to 4, and then gets out of there. And the best way for me to show you guys that is to just I plus space J. So what this will do is it'll print out the value of the outer loop, the counter in the outer loop, and then it'll print out the counter of the inner loop. And as you can see, it creates this pretty pattern with it going, okay, so while I is 0, J just kind of went from 0 to 4. And then J's loop finished. And then the I loop checked its condition again. Of course, 0 hasn't moved anywhere because it just incremented to 1. And then 1 obviously is less than 5, so we run the for loop again. And that for loop, once again, it sets J to 0. And the process repeats with the I being 1 and the J going from 0 to 4. And this happens for each one until this hits 4, and then you get like 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, so on and so forth. And these are really useful for creating like patterns and repeating things multiple times. And something that is actually pretty curious is that you can set the value, and this is where it gets really complicated, so just let me nerd out for a little bit. You can set the value of the inner loop, the amount of times it runs, you can have that be variable. You can control that. Like you can have it, oh, if I is this number, you should run the inner loop 5 times. But if it's this number, run it 20 times. So on and so forth. Then you can get like pyramids out of this. So if I wanted to print out I plus J this time, you'll see it's very different. It goes 1, 0, 2, 0, 2, 1, 3, 0, 3, 1, 3, 2, 4, 0, 4, 1, 4, 2, 4, 3. And why is that exactly? Because we can map this out in our minds. The very first run, which was 1, 0, happens when I is 0, this J is less than, this becomes 0, right? And 0 is not less than 0, it's equal to 0. So the inside doesn't run at all. When I becomes 1, J goes from 0, okay, it increments, it returns 1, 1 is not less than 1, all right? Kill that, go on. That's where we get this 1, 0 from. Then when I becomes 2, something interesting happens. Because J can now kind of like, it expands its boundaries. It goes from 0 to 1. And then when I becomes 3, it goes from 0, 1, 2. And when it becomes 4, it becomes 0, 1, 2, 3. So you can create patterns out of this, essentially. You can have it like write you a little pyramid. Like, let me show you how to do this. So if I just print out J, and I add a little sys out here, run that. Check that out. Little stack right there. 0, 0, 1, 0, 1, 2, 0, 1, 3. But that's a problem that you guys will find out in the loops and arrays questions. What I wanted to drive home about nested for loops is the fact that they are most commonly going to be used to iterate through two-dimensional arrays. So let's take a look at our jagged 2D array from up here. My 2D array 2. So there are rows and columns to 2D arrays, as we learned. So what we usually do is, because rows kind of hold more, I guess, information within them per se, it's kind of practice to iterate through 2D arrays from left to right of each subarray, etc., etc. So what does this mean? All right, so we want our row to change not that frequently, right? Because we only want to skip from this to this to this, right? But within each skip, we need to have a number go up a bunch, go up a bunch, and go up a bunch. Just like you saw before, there will be a number that will stay still while another one increments itself, all right? And when that's done incrementing itself, it'll reset, and then this number will jump up. This will increment itself. This will jump up. This will increment itself again, which helps us get through a 2D array. So what I'm going to do right here is sys out, and then I'm going to do my 2D array 2. And of course, we have to have two bracket pairs for accession. And I'm going to put I in here because I, of course, is the first bracket, right? It accesses the rows, and we don't want the rows to change that commonly. We want the rows to change when the columns are done being scanned through. And the J will be put in here because the columns will kind of be scanned through quickly. It'll be like, okay, chunk, first row, scan, second row, scan, third row, scan, like that. And what we do for our conditions here, like the looping conditions, is we set it less than my 2D array.length, which is normal, right? Like the length of my 2D array is 3 because it has 3 subarrays within it. However, each array within this 2D array has a different length. 3, 4, 2. So this is where you can change the conditions of the inner loop. We have my 2D array 2, and we get I, and when you're just accessing I, you are accessing this entire array. So this right here is an array. That my 2D array 2, and then like accessing I, that you're accessing an array. You're not accessing an integer. And then I get the length of that array, which for example, say we're at iteration 0. All right, I is 0. 0 gets plugged into here. My 2D array, the 0th index. 0th index is this right here. Okay, that is now our array. Ignore everything else. What is the length of that array? The length of that array is 3. J less than 3. J 0 to 3. 0, 1, 2. All while I is still 0. 0, 1 0, 0, 0 will get us this 1. 0, 1 will get us 2. And 0, 2 will get us 3. And then I will then chunk up to 1. 1, 0 will get us 4. 1, 1 will get us 5. 1, 2 will get us 6. And 1, 3 will get us 7. Finally, I will chunk up to 2. 2, 0 will get us 8. And 2, 1 will get us 9. If you don't believe me, I will run this code. You see, it just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, which is exactly what's in here. And that is, well, that's how you iterate through 2D arrays. And there will be a lot of problems. Well, not a lot, but there are some problems with nested for loops. I forget if I made one with 2D arrays, but yes, there is one with 2D arrays that you'll be dealing with in loops and array questions. Again, guys, this stuff is relatively complicated, so please don't be afraid to like ask for help and ask each other. Ask me, ask Mustafa, Zach, Vibhav, any of us. We're here to help you. And of course, you got Stack Overflow, as always. All right, the final concept I'm going to teach for this very, very large video, I really hope this is recording, is while loops and breaks. Get this out of here. And don't copy this down just yet. I will step through this code with you after explaining what a while loop is. A while loop is, in my mind, it's a very flexible for loop. it doesn't have the rigid structure of a for loop with an initial condition and like a run condition and an incrementation. It just says, all right, I'm going to check for a Boolean expression. If that Boolean expression is true, I will run myself. And at the very end of running myself, I will check that Boolean expression again. If it has changed, if it is now false, I will not run that. But if it is true, I will run it again. So how you make a while loop is you just say while, and you open and close parentheses, and then you open and close brackets. And what goes inside this pair of parentheses, think of it like an if check. You need a Boolean, either true or false. And of course, you're never really going to put like it's unreachable code. Like it says right here, you never want to put a while false loop. That will just not run because it'll say, all right, what's in here? Oh, it's false. Why do I exist? All right, move on. But if you have a while true loop, this will run forever. This right here is going to run forever. As you see, the highlights rest of the code, this is now unreachable because true will never change. It's a constant. It's a constant true. And this while loop will keep checking for true, and it'll keep running itself. Which is why you don't usually put the words true or false in there. You put a Boolean that can be changed based on conditions within the while loop. So for example, we have a Boolean called isRunning. All right, I just called it isRunning, and I set it equal to true because we want this loop to run at first, right? I made a scanner. You guys are familiar with that. And I set my while loop condition to isRunning. So this reads like English. While isRunning, run, obviously. But in machine code, this basically says, I will run this loop while isRunning is equal to true because isRunning is a Boolean. So let me step through this code with you guys. And if you can figure it out before I get to it, bravo, good job. This very, very first line just tells us type something in to echo it and then type Q to quit. We get the input from the user and then we check, is that input Q? Let's go for the more common case and say, assume it's not Q. If it's not Q, we'll type in echo and then give the input, which is echoing the input. Say it is Q, right? Input dot equals, remember that string method from before. We will print out the words exiting. We will change isRunning to false, and we will do something called break. Now, break is really commonly used, even though it looks kind of like a fancy purple word in the middle of all this, right? What break essentially says is, if you reach this line of code right here, get out of the loop, no matter what's going on. Even if the condition has not been met, get out of the loop. And the reason I'm using this break is, you'll see, first I'm going to remove it so you can see how the code works without it, and then you can see how the code works with it. So let's run this. So type something into echo it, type Q to quit. If I type in WASD, echo WASD, just like we said right here. And the beauty of the while loop is now, instead of quitting the program, like if we didn't have the while loop, it just goes back to the top and asks me to type something in again. Now you can see immediately how this can be applied to your calculator project, for example, where you can keep asking for input over and over again and just, plug away at it. And you can do this for the derivative calculator as well. So you have like a calc test on like just the power rule. You can just like type that in on the side. I wouldn't recommend it, but just saying, computer science is really powerful. And so I can just spam some stuff in. I can do this as many times as I need to. But say I want to quit. If I type in Q, it'll read it in. It'll check that it equals Q. It'll say exiting, say isRunning to false, but we remove the break. So what do you think will happen if I type in Q? Just think to yourself a little bit, looking at the code. Let's find out. Oh, whoops, no, not there. It said exiting, but then it echoed. We didn't want it to echo, we want it to quit. So that's where break comes in. As you can see, this whole setting is running to false. It worked. It killed the loop afterwards, because you can see the code stopped running. It didn't ask me to type something in again. It killed the loop, but at the expense of actually running it one last time, like a dying breath. What break does is it just kind of like snaps the loop's neck at the very end. It says, okay, I don't care, you're done. So what I'm going to do is I'm going to run this again with this break in there this time. I can type in something, maroon, and then like something like that. But now if I type in Q, just exits and doesn't echo me again, which is what we want it to do. That's usually how interfaces work. You don't say calculator exit and it randomly spits out 5 times 5 is 25 and then kills itself. That's not how it works. It just exits immediately. That's what break is for. Break lets you exit the loop, and you can use this in for loops as well. Say you want to run something until you find something, and then there's no real reason to keep running the loop. That's when you use break. Say, oh, I'm going to keep searching for the number 5, and as soon as I find the number 5, I want to get out of here. That's when you use break. If value equals 5, break. Exit the code. There's no need for the loop to run. At that point, it's extraneous. So that is the power of while loops and the power of break. You can apply it to for loops as well. You can technically iterate through arrays and while loops. You just have to make your own counter variable outside the while loop, increment it yourself inside the loop. Like I said, it's just a more flexible for loop. And that is everything for this very, very long section, loops and arrays. I hope that made sense to you guys. If there's anything that confused you, I will try and put timestamps in the video so you can click back to like the big topics, like what is an array, 2D arrays, for loops, nested for loops, while loops, and break. You can just check those 5 concepts off. If you need to rewatch part of the video and also DM me, I'm always here to help. I can sit down and also talk with you guys one-on-one if you need to. There are a bunch of questions in this loops and array questions document. You can find this on the GitHub, and I will also be sending out the link with these 2 videos. Please, 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 please. I'm like, if you were in front of me, I would like beg right now. Just finish these problems because they are extremely important. Everything else, I've kind of just given a strong recommendation to finish. But this, I really hope you guys take the time to finish these. And I mean all of them. And for the first time, I was able to make a 5-star problem. And it's kind of in my head right now. I really want it to be something that's like, oh, I want this 5-star problem to be something that like I or like Mustafa or Vibha would make to make their lives easier, because that's what I use computer science for usually, not algorithms or anything. I use it to make my life easier, right? That's why I learned to code in the first place, to make my life easier. And this is one of those things that will make your life easier. It's an outfit maker, and I'll give details on that to come. Might even make a video about it because I'm really excited to get this project shared with you guys. But until then, keep coding and let me know if you have any questions. All right, that's all, guys. See ya.